Hello friends, MoNaCo here, our sixth and second to last lecture on our solutions unit. We're covering concentration here and how we calculate those for various solutions using the equations from table T. Very short lecture here, and off we go. So you got to have your reference table T here, so do these calculations. So we've heard of concentrations before, like dilute and concentrated, but how do we actually calculate them? Dilute is a little bit of solute and a lot of it of solvent, and concentrated is a lot of bit of solute and a little bit of solvent. So concentration is a ratio, it's a measurement of how much solute to how much solvent, because we chemists, we got to put numbers on things. We love measurement and numbers. That's our thing. So check it out. Calculation concentration. All these formulas can be found on table T with one exception. Okay. Use your following methods to calculate the concentration of the solutions below. Show your work. So, as always, I want you to put out the formula. I want you to insert the numbers into the variables, and then I want you to calculate it. For table T, I have molarity. Molarity is the formula, so molarity equals moles solute per liters solvent. And the units we usually use are a big capital M, are the units. So in this particular problem, it's giving us an example. What's the molarity, keyword, of a solution that contains 4.0 moles of NaOH and 0.50 liters of solution? So in this case, we don't know what our molarity is. We know what our solute is. That's 4.0 moles. And we know our solvents equals 0.50 liters. So we have everything we need in order to plug it in. So X equals 4.0 over 0.50, and that equals your answer. The bottom of your sheet has got the answer that you should check on. Okay, I'm not putting it up there for you because you got to check that yourself. Okay, so make sure you do your math correctly. And let's move on to the other calculation, parts per million, or ppm. So the formula you got to use here is ppm equals the mass of solutes over the mass of solvents. Now, instead of times 100 like we do percentage, we're going to multiply by a million. Why? Because it's parts per million. Now, when we come down here to the bottom, we're going to do our maths to check it out. Approximately 0.0043 grams of oxygen can be dissolved in 100 mils of water at 20 degrees Celsius. This should say 100 grams of water, by the way, so change that. Express this in terms of parts per million. So ppm equals X. We don't know what that is, but the solute equals 0.0043 grams, and the solvents, well, that equals 100 grams. So when you set it up, X equals 0.0043 divided by 100. Now here's the hard part, times a million. What is your answer? And the units are ppm, parts per million. That's it. Check your answer on your homework sheet to see if you did your math right. I'm sorry, on your notes sheet to do your math right. Now, the last two calculations for concentration follow the suit. Percent by mass. We've done this a few times. Percent composition. It's the same thing. Percent by mass equals the mass of part by the mass of the whole times 100, because we got to get to percent. Units are percent, are units. Now, when we set up our problem here, what is the percent by mass of sodium hydroxide if 2.5 grams of NaOH is added to 50 grams of H2O? Well, percent equals X, so the part is the 2.50 grams, and the whole, it's got a little twist on it. Whole's got a little twist on it. It's not 50 grams for the whole, because notice it's added to 50 grams of H2O. So if you add 2.5 grams of solute to 50 grams of solvent, the total mass of the whole is actually going to be 52.50. So be careful, because masses do get added together. Okay, the way these problems are worded. So our x equals 2.50 divided by 52.50 times 100 here equals our answer in percentage. So check your answer there in the bottom right corner of the box. Now this is the only equation that's not on our table T, but it's identical to the percent by mass, except that we say percent by volume equals the volume solutes divided by the total volume. So in this case, we do the total volume instead of the mass of the whole, so I could say the total mass, kind of in the percent by mass thing. So total volume, and to get the percentage, you got to multiply by 100. So here we go. Let's just define our variables, or identify our variables instead of defining them. Percent by volume of alcohol of 50 mils of ethanol is diluted with water to form a total volume. See how I clarified total volume of 300. So in this case, we don't have to add. So x equals, well, percent volume. Let me just write that properly. I was doing that backwards. So percent by volume equals x. We don't know that answer. The solute is the littler one, so that's 50 mil. Solvent, or the solution, mass of the total volume of the solution, equals 300 mil. Because it says it was diluted to a total, we don't have to add. So now we get a percent by volume equals 50 divided by 300 times 100. That equals our answer in percentages. So percentages are the units there. I want you to check your answers with what is written on your homework notes there. So that is it for calculations, but there's a lot of practice. 13, 14, 15, and 16. 4 pages of practice in our practice pack. And there's no castle yet on this, because we're going to combine this one in the last lecture with the last castle that you'll have to do. So let's check ourselves off and see how we did. We got our lecture 6 done. We got our practice pack, 4 pages to do there, a lot of calculations. We got a POGO for you there on that stuff. And that's it for this particular portion of the unit. So thanks for watching.